So a frequently asked exam question is to show that cos2a could be written as cos squared a minus sine squared a. So the first part of this question really is to ask ourselves, is there any other way that we could write 2a, or twice an angle? And there is. Twice an angle is the same thing as having a plus a. So what we're really looking for is there a way to write cos of a plus a? And if you think back to our proofs, there is a formula, a compound angle formula, that deals with a plus b. And that tells us that it goes to cos of a, cos of b, sine of a, so minus sine of a, sine of b. So instead of having now a and b, we're actually dealing with a and a. So all of the b's here are going to become a's. So that's all we have to do, is break down 2a into a plus a. Now we're dealing with the compound angle formula, and we substitute back in. So we're going to have cos of a plus a becomes cos of a minus sine of a, sine of a. And what we can say here is that cos of a multiplied by cos of a is the same thing as having cos a all squared, minus sine of a by sine of a is the same thing as having sine of a all squared. And there is another way that we could represent this, and that is by saying cos squared a. That's another way of writing all of this. And sine squared a. And of course, that's what a plus a was. In other words, what cos of 2a could be represented as. Now, this could be extended further, and they could ask us to show, and it has come up in the past, that cos2a, show that that could be written as 1 minus 2 sine squared a. So the difference between this line here, which we've just been able to prove using the compound angle formula, and this one, is that there's no cos squared a. It's been replaced by a 1, and we now have a second sine squared a involved. How does cos squared a link to a 1 and a sine squared? Well, in the log tables on page 13, you'll see that cos squared a plus sine squared a is equal to 1. So I could replace cos squared a with what it's equal to, which is 1 minus sine squared a. So that's just manipulating the formula that's in the log tables on page 13. So I'm going to replace that in the formula we were just proving. So I'm going to copy and paste that formula. So that cos squared a can be replaced with 1 minus sine squared a. So this one right here. And when we do that, then what we're going to have is cos 2a is equal to, and then I'm going to replace it with 1 minus sine squared a, and then we had our minus sine squared a in there. And then I have 1 minus sine squared a minus sine squared a, so that's going to be minus 2 sine squared a's. And those are the proofs that you could be asked in relation to cos 2a.